Okay, today we are going to look at section 3.1 and continue talking about lines and things about lines. And in section 3.1, we are going to examine what's called systems of equations. So we've solved linear equations. Now we're going to talk about solving what's called a system of equations. So here is an example of something that is a system of equations. Looks like this. X plus y is equal to 6. And then 4x minus y is equal to 14. Yes. So it's called a system of equations. Notice what makes it a system. The reason we call it this is because there are two equations. And when we solve a system, what we want to know, is there an x and a y value? Is there an ordered pair that solves both at the same time? Okay, so when we solving one of these means finding an ordered pair that works in both equations. So our eventual goal, what we are going to spend most of our time doing in this section, is actually finding solutions to these things. Just give me time to write that down, just making sure we're all. I'm hoping that this is not the worst thing in the world that we've done. We changed cameras here for some reason, not sure why. So what we're going to do first, before we actually solve something, is I'm going to ask you this question. I'm going to do one and you're going to do one. Here's what I want to know. I want to know, for this system right here, I want to know, is the point 4, -2, I think that's what my example is. No, just 4, +2. Is 4, +2 a solution? So this is the first question, trying to understand what makes something a solution to a system of equations or not. So what we're going to do is we're going to look at both equations. And if my answer to this is going to be yes, that means that this point has to work in both equations. If it doesn't work in both, then the answer is no. Okay, it has to be a point that works in both equations. So here we go. I'm going to take the point 4, 2, and this says x plus y is 6. So let me write that right here. X plus y is equal to 6. So I'm going to put 4 in for x. I'm going to put 2 in for y. And is 4 plus 2 6? Is that a solution? So far, so good. Yes, 4 plus 2 is 6. A little Monday arithmetic. So far, so good. But I can't stop there. I have to check both equations. Okay, it doesn't matter. It doesn't matter if it only solves one. Okay, it has to be a solution for both. So I'm just going to draw a little bar so that I can keep these two things divided. And so the next equation is 4x minus y is equal to 14. And now I'm going to do the same thing. I'm going to plug in the x value 4 and the y value 2. And we're going to see, does it create a true statement? So here goes. X value 4. 4 times 4. When I put 4 in right here, 4 times 4 is 16. The y value is 2. And is this a true statement? Is 16 minus 2 equal to 14? Yeah, I think my calculator is going to agree with that. So is this ordered pair a solution? Well, since it worked in the first equation, since it worked in the second equation, I can answer yes. That is indeed a solution. So I'm going to give you a system, and I'm going to give you an ordered pair, and you're going to answer this same question for me. So your system is this. 2x plus y is -6. And the second equation is x plus 3y equals 2. And what I would like you to check is I want to know, is the point 3, -12 a solution? So you're going to check that for me, please. I'm going to try this out. I'm going to have you do it for another ordered pair just so that we get a little practice before we move on from determining if something's a solution to actually solving it. So 2x plus y is -6. I'm going to start with that one. And so my x value is 3. So 2 times 3 is 6 plus the y value. The y value is -12. And is 6 plus -12 equal to -6? Is this a true statement? Yes, it is. Okay, so far so good. We're halfway there. So that one works, but remember we have to check both. You can't answer yes now. You can't assume. So the next equation is x plus 3y is equal to 2. So my x value is 3. My y value is -12. So 3 times -12 is -36. And is 3 plus -36 equal to 2? No, it is not. So that is not true. 3 plus -36, your calculator is going to tell you is going to be -33. That is a long way from 2, so it doesn't work. So this point, it works in one of the equations, but it doesn't work in the other. So is it a solution to that system? The answer to that question is no. For that same system right there, just to get a little more practice in, the first type of question you're going to be asked to do on your homework, there'll be one of these on the quiz, determining if something is a solution. So it's a nice place to start. Use that same system right there. This time we're going to do the point is -4, 2, a solution. So you're doing the same two equations for that form that system. You're doing it with this. All right, I'm going to get started on this one. We're determining if the point -4, 2 is a solution to this system of equations. So the first equation is 2x plus y equals -6. So I'm going to put my x value and my y value. Remember, my ordered pair is always the x value and the y value. That never changes. So 2 times the x value, 2 times -4 is -8, plus the y value is 2. And then you can check in your calculator, is -8 plus 2 equal to -6? Yes, so far so good, we're doing great. The other equation is x plus 3y is equal to 2. So the x value is -4 plus 3 times the y value is 2. So 3 times 2 is 6. Oops. And again, -4 plus 6 is equal to 2. That point there works in both equations. It gives me a true statement. That's what I'm looking for. And so is -4 and 2 a solution? And the answer to that is yes. So the purpose to these first 2 problems is just to show you what makes something a solution. A solution works in both equations. If it only works in one, it's not a solution to the system. It has to work in both for us to say it's a solution to the system. Now, the purpose to my next problem is I've told you what a system is. A system is 2 linear equations that we're considering at the same time. Okay, that's what a system is. The second thing I've told you is a solution is an ordered pair that works in both. Now, I just want to relate this to what we've already done in the past with graphing lines so we can see what's going on with this system. So here's an example. I gave everybody a piece of graph paper. Somebody walked in though when I was writing. So here's what we're going to do. We're going to take this as an opportunity for some review as well. So here's what I would like us to do. We are going to solve the following system, and we are going to do it by graphing. So let's switch cameras and switch microphones so people can hear me. So here's what we're going to do. We are going to solve the following system by graphing. I'm going to write the system over here on this grid to the right just so that you can see it well. So the first equation is going to be 2x plus y is equal to -5. The second equation is going to be -x plus 3y is equal to 6. And what you're going to be asked to do, again, I'm just modeling for you the homework problems you're going to see. We are going to be asked to solve this by graphing. So here's what I would like you to do, and then I will help you determine what the solution is. This first part, 95% of this problem is just review. We've graphed lines. We did it before the test, and then we did it in one of our sections after the test. So what I would like you to do, using the slope and the y-intercept if you're able, or using the x and y intercepts if that makes you happier, graph both of those lines on the same coordinate plane. Okay, so graph both of them on the same coordinate plane, please. All right, so the first line I'm going to do in red, I've already solved it for y. So it starts out as 2x plus y equals -5. If I am going to solve this, or excuse me, if I'm going to graph this using the slope and the y-intercept, I need to solve for y. So remember, you can graph this using the intercepts. You can graph this by plugging in points. I'm not super concerned, but finding the slope and the y-intercept long-term, when you get to college algebra, that will be the more profitable way to do it. So I'm going to subtract 2x from both sides, and that gives me the equation y is equal to -2x minus 5. The slope is always the number in front of the x, so that's -2, which I put over 1 so that I have an x direction and a y direction. And then my y-intercept is -5. So I'm going to come back over here to the grid. My y-intercept is -5, so that is this point right here. And then the slope being -2 over 1 means I go -2 in the y direction and then 1 in the x direction. So -2, 1, -2, 1. We can go the other way. We can go +2, -1. It doesn't matter. So now I need a straight edge. So I will pull out my lovely driver's license and I will connect these dots. So we talked about graphing. If you are confounded by graphing a line, okay, you need to seek help. Either find me, find a tutor. This is not going to go away. Okay, it was part of our first unit. It is also part of our second unit. Okay, there will be problems on the test that are going to require you to graph. Okay, so I need you to be able to do that. All right, the next one, I'm going to solve this for y. I'm going to add x to both sides. And I get 3y is equal to x plus 6. Divide both sides by 3. Remember to distribute that 3. So when I divide the 3 into the first term, that's going to be 1 over 3x, because remember there's a 1 in front of that x. And then the second term, 6 over 3 becomes 2. So the slope of this line right here is 1/3, and the y-intercept is equal to 2. So I'm going to plot the y-intercept of 2 right there. And then my slope is 1 over 3. So that is up 1 over 3, up 1 over 3, or down 1, back 3, down 1, back 3. Either way, and I will connect these dots. Okay. Excellent. So then here's the reason we did this problem. It was not necessarily just so I could see if you could graph, which that's part of it. Here's my question to you. What feature about this graph, if we know that a solution to a system is a point that's on both lines, when I am looking at that graph, where am I finding the solution? Why -3,1? What's happening at -3,1? The lines overlap, they intersect, they go over each other, however you want to phrase it. That's where those two lines crash into each other. So yes, the solution is this point right here, which has been identified as -3,1. That's great. And the reason that we found that is because that's the point where the two lines intersect. So pictorially, which is the reason for the problem, pictorially, what we're doing when we find the solution to a system of equations is we're finding where the two lines intersect. Now, graphing is lovely, but that is not going to be the best way for us to go ahead and solve these, because what happens if the answer is a fraction? What happens if they're hard to graph because of the numbers? What we're going to do now is there are two methods to solve systems algebraically. Okay, so if you've ever seen this before, this is probably the part, I guess, you've seen some bit of this if you've ever seen system of equations before. So the first way we're going to do is we're going to solve a system by substitution. This is the first method. We're going to solve by substitution. So here is our example. 2x minus y is equal to 6, and x is equal to y plus 2. So a question that is common to ask, you're probably thinking it right now, is, hey, Perkster, you said there's going to be 2 ways to solve. How do I know which one to use when? Well, the first answer to that is they both will always work. But I want you to have as happy of a math life as possible. Okay, so I want you to be able to use the easiest thing when possible. So my recommendation for you is we will use substitution when one of the equations has a variable that is easy to solve for, meaning one step. So we will use substitution when one equation has a variable that is easily solved for. Meaning it's just going to take me one step. I just got to add or subtract something and boom, I've got it. If it's going to take you more than one step to solve one of the equations for a variable, don't use substitution. Okay, you don't want to end up with fractions. Okay, use the other method. It'll be way cleaner when you have something that's not easy to solve for. Okay, so I'm trying to make this as nice and straightforward as possible. Now, this example that I gave you, I've already solved for one of them. I've pre-done it so that we can see how to do the substitution. So I'm just going to give everybody a moment to finish writing this down. And I'm going to do this example, and then I'm going to have 2 for you to do. You're going to have one that's going to be just like this, and then one where you have to solve for one of the variables. Or maybe we'll just do one example just because of time. I don't want to run over. Okay, so here we go. We're going to solve this. We are now going to figure out what's the ordered pair that satisfies both of these. So I said we are going to do this by substitution. What substitution means is this. This equation right here says x is y plus 2. So it says x is the same thing as y plus 2. So what I can now do is I can substitute it. What I'm going to do is I'm going to take x and I'm going to plug this in for the x in the other equation. I'm going to substitute it. That is the whole premise of the substitution method. So I've got this equation. It says wherever I see an x, that is the exact same thing as y plus 2. And so we're gonna substitute that. So here goes. I mentioned when we talked about functions in the last class, when I substitute things, my first step is I like to leave myself some parentheses so I know exactly where I'm placing what I'm substituting. So here goes. This equation says 2 times x. Okay, instead of the x, I'm going to leave a gap. Minus y is equal to 6. Now, according to this equation right here, instead of an x, what am I going to fill in the gap with right here? Y plus 2. There it is. That's the hard step. Okay, so once you're able to do that, you've done the hardest part to this. The rest of this is stuff we've already done. We're going to solve this, and then we're going to put the number back into one of the equations and get the other number. And the rest of this hopefully looks familiar. So I'm going to distribute. I've got 2y. 2 times 2 is 4. I'm going to collect my like terms. 2y minus y is 1y. I'm going to subtract 4 from both sides, and I end up with y is equal to 6 minus 4 is 2. All right, we're 85% done with the problem. We've done the hard bit. We have substituted. We've solved this equation. We've got the y value. But remember, our solution is an ordered pair, meaning there's an x and a y that go together. So now I'm going to take this y equal to any hypothesis. Anybody want to guess? What am I going to do with this y equal to 2? Yeah, I'm going to substitute it back. Hey, Perkster, which equation? Well, really, it doesn't matter. But again, I like to do the easiest thing possible. So since this equation is already solved for x, we already went through that effort, I'm going to put the y equals 2 in right here. Okay, so I've got x, so I'm going to just draw a little arrow. I've got x is equal to whatever my y value is. I'm going to put a parenthesis plus 2. Well, my y value is 2, so I'm going to pop that in right there. And 2 plus 2 is 4. The last step's notational. Whereas we have solved the system of equations, we have found the point where these two lines overlap. So we're going to write it as a point. We're going to write our solution as an ordered pair. So it is the x value 4, it is the y value 2, and I'm just going to throw some squigglies around it so I don't think that that's an interval on the number line. That's an ordered pair because those two things look the same. All right, you're going to do the same thing. Here's your first equation. 5x minus 3y is negative 6. And then x is equal to 2 minus y. Solve that by substitution. I've already pre-solved one of the equations for the variable x for you. All right, substitution method. So I see a lot of you not writing. I hope that's good. I hope that means that you worked through this. And I hope you're not just waiting for me to do it. Okay, practice is what is going to put this into your memory. So this one has already been solved. X is the same thing as 2 minus y. So I'm going to take this x and I'm going to plug it in for x in the other equation. So the other equation is 5 times whatever x is. So I'm going to leave a gap for whatever x is. Minus 3y is equal to negative 6. Instead of x, I know that x is the same thing as 2 minus y. So I'm going to throw a 2 minus y in right there. Again, that's difficult. That's the new thing. That's the substitution step. Solving an equation, that's from the first day we met each other a few weeks ago. I'm going to distribute 10 minus 5y. I've got a negative 5y and a negative 3y. When you throw that into your calculator, that's negative 8. I'm going to add 10 to both sides. All right, well, we'll keep going. So I'm going to add, I just was looking because we're going to end up with a fraction, and that was not my intent on this first problem, so I apologize for that. Negative 6 plus 10 is 4, and when I divide both sides by negative 8, I get y is equal to 4 divided by 8. A positive divided by a negative becomes negative. 4 divided by 8, that's a half, or 0.5 if you prefer decimals. Either way. Where did the 10 Yeah, it's positive 10. Oh, thank you. I knew that my first example wasn't supposed to have fractions. I appreciate you finding my error. It's Monday, everybody. Mondays apply to me too. So here's what I did wrong in case you're sitting there and you're not laughing at me. That's also an appropriate response. I did 5 times 2 and got 10, which was right. But then for some reason, when I moved it down, I made it a negative 10 for some unknown reason. So I apologize for that. I'm going to erase this. That should be a positive 10. Okay, this is good. So now I will subtract 10 here. So 10 minus 10, that cancels, and I have negative 8y. And then over here, negative 6 and negative 10 is negative 16. And we get, not that fractions are bad, but I just did not want to get a fraction on the very first problem. That would have kind of felt like I was being mean. So negative divided by negative is positive. 16 divided by 8 is 2. There's my y value. And now I'm going to go back. I'm going to substitute. You can use either of these two equations. Okay, you'll get the same answer either way, but I'm just going to use the one that's already set up to be solved for. So I've got the x is equal to 2 minus y. So 2 minus whatever I'm plugging in, which is going to be 2. And the x value is 0. That's okay. 0 is a number. We're happy with it. So my ordered pair is the x value 0, and then the y value is 2. There's my solution. One more substitution. Since I seem to have an issue with that one, I need a little more practice myself. So here's one more, and you're going to help me define the first step before we get moving on this one. So this problem is 4x plus y equals 5. And then the second equation is 2x minus 3y is 13. Give you a moment to write that down, then I'm going to ask you a question before we get started on this problem. I'll give you a couple minutes to work through. I told you that substitution is a fine method to use, but substitution is best used when one equation has a variable that is easily solved for, meaning it's just going to take me one step. So looking at these two equations right here, what is the variable in which equation that is the easiest one to solve for? The y on the top. Why did you determine, so help everybody, why did you determine the y on the top is the easiest one to solve for?
Take the 4x, put it on the other side.
Perfect. There's nothing to divide by. Does everyone see that there's no number in front of the y? There's a 1 there, so there's nothing to divide by. So this variable, when I say when one equation has a variable that's easy to solve for, you're looking for a variable that has no coefficient in front. That's what I mean by the easiest thing to solve for. So here's what I'd like you to do. Step number 1, I want you to take this equation, solve it for y. Do it. I'm going to give you 30 seconds. Top equation, solve it for y. It's one step. What did you do to both sides to solve this equation for y? Perfect. Subtract the 4x. Yes, that is indeed what I want to do. I'm subtracting the 4x from both sides. Okay, so 4x minus 4x on the left leaves me with just y. Perfect. And then on the right, I have either 5 minus 4x. You can write it 5 minus 4x. I just like to put the x's first. So I've got negative 4x plus 5. Either way is fine. Here's the next thing then. You solve for y. Now substitute. Take that, y equals, and substitute it for y in this equation right here. Now find me the solution. What's the ordered pair now from there? All right, I'm going to get started on the substitution. If you're still working, keep working. Check what you've got with what I get. But we took the top equation already. To summarize, we solved it for y. We got y is negative 4x plus 5. So now I'm going to substitute that into the other equation. So the other equation is 2x minus 3 times y. Y is what I'm substituting, so I'm going to leave a little gap, is equal to 13. So I'm going to now plug in y is the same thing as, that's what equals means, y is the same thing as negative 4x plus 5. So negative 4x plus 5 right in there. Hopefully I'll get my signs right, but I know that you'll be keeping tabs on me to make sure I do this well. I've got 2x, negative 3 times negative 4 is positive 12x. Negative 3 times 5 is negative 15. Going to collect those like terms. 2 and 12 is 14. Just going to take this and bring it up here so everybody can see. So we've got 14x minus 15 is equal to 13. I'm going to add that 15 to both sides. Again, solving. We've been solving equations since the first day. I'm hoping that that is falling in line for you. If it's not, let's talk and get you caught up on that. Divide by 14, and you get x is 2. There's my first bit. X is 2. Again, you can substitute x is 2 anywhere you want, but where I'm going to substitute it is where I've already done some work. Okay, I've already got this equation set up that it already says y is something. So I'm going to plug the x equal to 2 in right here. So I get negative 4 times whatever the x value is, and that's 2. Negative 4 times 2 is negative 8. Negative 8 plus 5 is negative 3. I've got my x value. I've got my y value. We're good. We're just about ready to celebrate. But before we do that, we've got 2, negative 3. There is our solution to this problem. So that's the substitution method. Perfectly good method. Okay, nothing wrong with it. You're welcome to use it any and every time you want to solve any system of equations. Okay, but there is a method that I like better because it works no matter what. Even if you got fractions, you can tend to avoid fractions using this. So the second way to solve we are going to solve this system by what's called elimination. Sounds much tougher. Okay, elimination. So here's my example. It's going to be 2x plus 3y is equal to 6. And then 4x minus 3y is equal to negative 6. Give you a moment to write that down. And then I'm going to, the purpose to this problem of mine and your first problem is just so that we can see what the premise of elimination is, what I want to do. And then we'll each do a problem that is, that's a little more difficult. So here is the premise behind the elimination method. I noticed this. If I was just to add these two equations together, if I was to add the x's, the y's, the numbers on the other side, what curious thing do you notice happens with the y terms? They cancel out. They're eliminated. Okay? That's what we want to do with the elimination method. We want to get one of the terms in each of the equations to look the same. And then when we add them up, they just cancel. So I'm going to just do that. Here's the elimination step. This problem was given to us, set up, ready to eliminate. Okay, nice one-step problem to learn what this method is telling us. So 2x plus 4x, that's 6x. 3y minus 3y, well, that's the elimination. 3y minus 3y, those cancel, that's eliminated. And then 6 minus 6, 6 minus 6 is 0, so I need something on that side, so I'm going to write a 0. In short, that's what the elimination method is. I want to eliminate one of the variables. Okay, we were able to do that in this problem because I had a positive 3y and a negative 3y. When you add those two things together, they go away. Now I'll divide both sides by 6. And look at that, nice and quick. I've got my x value. My x value is 0. My y value is found by picking your favorite equation here. Doesn't matter which one. And you're going to substitute. I'm just going to use the top one because it's on top. Okay, I have no secret reason. I have no secrets from you. There is no reason that I'm picking this that you don't know. So I'm going to take x equal to 0. I'm going to plug it in up here. So 2 times x, which is 2 times 0, plus 3y is equal to 6. 2 times 0 is 0. Goodbye. Divide by 3. And I get y is equal to 2. So my x value is 0, my y value is 2, and there it is. I've just solved that using elimination. So your first example is going to be much like my first example. It's going to be set up, ready to rumble. All you're going to have to do is add these equations together to do the elimination part of this. So yours is 8x minus 2y is equal to 5. That's the first equation. The second equation is 5x plus 2y is equal to negative 18. I would like you to solve that using the elimination method. It's all set to go. I'm going to get started because hopefully the arithmetic on this went pretty well. Okay, so again, I asked to solve this using elimination. In fact, I pointed out to you this one's set up just so that we can practice this. The negative 2y, the plus 2y, those two things are opposites. So they are going to eliminate when I go ahead and add these two together. So once you have that, because in the next problem, our job is going to be to create this situation. Okay, because not all equations are just going to be laid out for us to do straightforward like that. So once you have it though, it's just a matter of adding the equations together. 8x and 5x, that is 13x. The negative 2y plus 2y, those two things cancel. And then on the other side, 5 minus 18, your calculator will tell you that's negative 13. I divide now. There's one step. I'm at the solution. The x value is negative 1. Again, I'm just going to use the top equation just because it's on top. If you want to verify that we will get the same y value if you use the bottom equation, you will. Okay, you'll get the exact same thing. Sign, everything will be the same. So the top equation is 8 times x minus 2 times y is equal to 5. That's negative 8. I'm going to add 8 to both sides. And divide by -2. And positive 13 divided by -2 is -13 over 2, or -6.5. And notice in this problem, because we eliminated, the fraction was almost painless. Okay, so I just got to look at it. I don't have anything I need to do with it. So the x value is -1, the y value is -13 over 2, and there is my solution to that system of equations. All right. My last example, and then I've got 2 or 3 for you to do, just to show you different aspects of what we're doing here. So here's mine. I've got 5x minus 2y equals 4. Then I've got 2x plus 3y is equal to 13. Let me give you a moment to write that down. Then I have a first question. You're going to talk me through this problem. Do I have 2 terms that are exactly the same but opposites here? Can I just add this up and cancel something right away? Not in this one. So please do not do this. I know 5 and 2, that's 7. -2 plus 3, that's 1y, and 17, that does you no good. You're not any closer to the solution doing that. What we have to do is we have to now multiply each equation by something to create this situation right here. So you tell me there's no right, there's no wrong answer to this question. Do you want to eliminate the x's or the y's? Y was the first thing I heard, so that's what we're going to go with. Doesn't matter what you had picked, okay? We can do it either way. We are going to eliminate the y's. So here we go. I've got a -2 in front of that y. I've got a 3 in front of that y. Between 2 and 3, what's the common multiple? Yeah, 6. 6 is going to, you can use any common multiple. You can use 12, you can use 24 if you're really feeling like it, but I like to use the smallest number possible. So I'm going to use 6. So here's what we're going to do. We're going to multiply the top equation by something so that it'll be -6. We're going to multiply the bottom equation by something so it'll be +6. And then we'll have the exact same situation as we have right there. What should I multiply the top equation by? When I multiply by 3, 3 times -2 is -6y. So I'm going to have a -6 in front of the y. Tracking with me? Anybody got a question? What am I going to multiply the bottom equation by? Okay, I'm going to differ with you on one thing. You're close. What was set up here, in case you did not hear, is -2. But here's why we don't need the negative on this one. Okay, in other problems, that would be the right thing to do. But in this problem, we already have the negative up here. This was already 3 times -2. This is going to be -6y right here. So if I do -2 here, -2 times 3, that's going to be another -6y. Are those the opposites? Are those going to cancel when I add them together? No. So good thought. Okay, I appreciate it. We do have to be very conscious of the signs here. What then should I multiply this bottom one by? Positive. Yep, you're right. You caught it. I saw that you caught it even before, but I wanted to go through because you're not the only one. I want to make sure everybody's catching on to that. All right, so difficult stuff. Okay, I understand. We're learning this. Many of you are learning this for the first time. I got it. Okay, so what you want to do, here's your end goal. You want to create this situation where you have opposites in front of one of your variables. We could have done it with the x's. The common multiple of the x's is 10. And I would have to multiply one of them by 2 and one of them by -5, or -2 and +5. So that would have a positive and a -10. Okay. All right, let's keep going. I'm going to multiply the top equation by 3. So 3 times 5, that's 15x. 3 times -2, that's -6y. 3 times 4, that's 12. What you've done is you don't need to know this. It's just fun math information. You just created a multiple of the original equation. It's the same exact thing. Okay, the line here and that line there, if you graph them both, would look exactly the same. Okay, so we've not changed anything. The bottom equation, 2 times 2 becomes 4x, 2 times 3 becomes plus 6y, and 2 times 13 is 26. And I've met my goal. My goal was to have opposite things in front of the y's. I've got that. So now I'm going to add everything together. The rest of this problem is now just like that problem. There's no difference. Okay, once you've done 1 or 2 of these, there's no other mysteries that can possibly be. So 15x and 4x is 9. This y's cancel, which is what I wanted. 12 and 26 is 38. My x value is 2. You take my x value 2, randomly pick one of these equations. It absolutely has no bearing on your answer, that you're going to come up with the same thing. I'm just going to keep using the top equation because I don't see any reason that one of them is better than the other. So I'm going to use this top equation. So I've got 5x. So I put in 2 for x. 5 times x is 5 times 2 minus 2y equals 4. 5 times 2 is 10. And the rest of this, we've done this 1,000 times by now. We've solved all these equations. Solving equations never changes. It's always the same steps every time, every single time. So my x value is 2, my y value is 3, and there it is. There's my solution. So I would like you to do the same thing with this next problem. I want you to solve it by elimination. You're going to have to multiply both equations by something. What I'm going to ask you to do on this one is let's eliminate the x's just to practice doing that. Okay, I don't want anybody to think you have to always eliminate the y's or always have to eliminate the x's. You can pick either one. So I am declaring so that we all are doing the same thing. So this equation, this system is this. 2x plus 3y is equal to 19. And then 3x minus 7y is equal to negative 6. So eliminate the x's, please. I'm not going to do the problem yet, but just to give everybody a nudge. If we're going to eliminate the x's, what's the multiple again between 2 and 3? 6. So you have a choice. Okay, you either did one of these two things. First, what should I multiply the top one by? Okay, I heard 3. So if you were a 3 person, okay, if you multiply the top one by positive 3, what did you have to multiply the bottom one by? Negative 2 to get opposites. Now, if you went the other way, there's no right or wrong here. If you were a negative 3 person in the top, okay, that's great, perfect. What did you have to do in the bottom? Positive 2, yes, opposite signs. Okay, so what you either did one or the other. I'm going to do the first thing that I heard. which was somebody said +3, and then we said -2. So if you were struggling with that, that's how I'm going to finish the problem right there. All right, I'm going to begin my work. If you're still working, keep working. Check what you've got with what I get. So I multiply the top equation by 3. 3 times 2 is 6x. 3 times 3 is 9y. And then 3 times 19, I think that's going to be 57. Is it 57? We're good. Thank you. Okay. -2 times 3 is -6. Negative times negative is plus 14y. And then a negative times a negative is plus 12 down at the bottom. So we accomplished my goal. I asked us to eliminate the x's. You could have eliminated the y's if that's what you wanted to do, but I chose x's, so we'll all do the same thing. 9 and 14, that's 23 y's. 57 and 12, that's 69. And now when I divide by 23, I get y is equal to 3. There it is. Nice. And again, favorite. There's no better, there's no worse choice up here. I'm going to use the top equation for no reason other than it's at the top. And so we've got 2 times x plus 3 times y. Well, the y value I found is 3. That's equal to 19. Pardon me. 3 times 3 is 9. And the rest of this just falls out. 19 minus 9 is 10. Lots of solving equations. So again, if you're struggling solving equations, that is a skill that's not going to go away all semester. Okay, we are going to be solving equations up till our last day together. So if you get into here, you're like, I still don't see what's going on. To solve that equation, we need to talk. Please, let's do that. Okay, I don't want you sitting there in the dark the whole semester. And there's my solution. All right, 2 more examples from this section, and then we'll hit pause and we'll start a new recording, and we'll do we'll begin the other section that we've got, and we'll finish that one on Wednesday. So here's your second to last example. It is this: 2x minus y is equal to 3. 6x minus 3y equals 9. Again, eliminate the x's on this one. Doesn't really matter, but eliminate the x's. All right, so if we're going to eliminate the x's, what are we multiplying by here on this problem to eliminate the x's? Okay. Okay, and bottom one would go up. Okay, so I'm going to go with it because there's nothing wrong with this. What I was told is we're going to use 12 as the common multiple. Now, the least common multiple will be 6. Okay, so I could just get away with multiplying the top one by something and not the bottom. But I just want to show that you can use any multiples. So I'm going to go with this. Okay, so if you used 6 as the common multiple, 12, 24, 18, whatever, you will all end up in the same place. So what I was told, I'm going to multiply the top one by 6, because 6 times 2 is 12, and then the bottom one by -2, because -2 times 6 will be -12. Okay, it's going to work great. So let's do this. 6 times 2x is 12x. 6 times -y is -6y. 6 times 3 is 18. The bottom equation, -2 times 6 is -12x. -2 times -3 is +6y. And -2 times 9 is -18. So this, something wild happens on us. I canceled the x's, right? But what have I also canceled? Yeah, the y's. And we didn't do it intentionally, it just happened. Okay, that was just the way the equation is set up. So what I wanted to show you is what to do when both your x's and your y's cancel and you have nothing on the left. Okay, there's no x's, there's no y's. I don't need a variable because 0 times anything is 0. On the other side, 18 and -18, those cancel too. So I end up with this equation right here, 0 equals 0. Is this a true statement or is this a false statement? Okay, it's true. Okay, so there's two special situations you're going to encounter when you're solving your systems of equations. This is the first one. You end up with a true statement. I'm not super concerned about terminology, but I know my math lab's going to ask you this. So what you'll call this is a dependent system. What it means is you have the same line. Okay, you just had two multiples of the same line. So if we were to graph this, it's going to be one line on top of the other. Okay, they're going to intersect everywhere. Okay, so I'm going to just make these little notes so that when you're reading through your notes and do your homework, you maybe jogs your memory about what we've been doing. Dependent system, what that means is we have multiples of the same line. So as far as my picture, that means they intersect everywhere. And here's how you write the solution. Or here's how this book. Different books do this different. I wish there was more consistency on how to write the solution. But here's how you write the solution to this. You're going to write a squiggly for a set. You're going to write an ordered pair of x and a y. This is going to say we are situating every x and y that satisfies this situation, or that satisfies this equation. And then we're just going to take the one that's reduced. So we're going to use the 2x minus y is 3. So this kind of goofy notation. So what we have communicated is that the solutions, the x's and y's of their solutions, are anything that's on the line. Okay? Everything on the line is a solution. That's what this is saying to you. Okay, so if that doesn't seem clear at first glance, maybe make yourself a little note that this is saying that my solutions, the ordered pairs that answer this, are all the points on the line. And that's how we do that. There's one other special situation. I'm not going to make you go through everything, but let's say that we have this -x plus 3y is equal to 4. Then the other equation that I have is -2x minus 6y is equal to 11. So just for time's sake, because I want to have the last 20 minutes or so to get started and get a good start on the other sheet. So we are going to eliminate the x's again. I need to get a 2 in front of the top one to cancel out with my -2. So what can I multiply by up here? That's going to give me a positive 2 in front of the x, so it'll cancel out with the negative 2 in front of this x. Yep, negative 2. A negative 2 times a negative 1, negative times negative is positive. That's where that answer comes from, in case you were struggling to see what that was going to be. So my top equation becomes 2x, negative 2 times 3 is negative 6y, negative 2 times 4 is negative 8. Did I do a typo again? Yes, I did do a typo. Good job, person. 2 for 2. Sorry about this. I'm going to change the sign on the 3y to a negative. That's my fault. Negative 2 times negative 3x plus 6y. So that changes that sign because I was trying to create something where all the x's and the y's cancel. So I apologize for that. So I just wrote down the wrong sign. Bless you. I wrote down the wrong sign. The bottom equation, I'm not doing anything to. And then here was my intended purpose for this problem that I goofed up the sign on. 2x minus 2x, that cancels. And once again, like the previous problem, 6y minus 6y, those cancels. So again, I only have nothing on the left side. No x's, no y's, just a big 0. But on the right, unlike this problem, where on the right, my numbers on the right also cancel here, negative 8 plus 11, this is 3. So we get the opposite conclusion. Is this a true statement? Is 0 equal to 3? No, it's not. Again, I'm not super concerned about the terminology, but when you're on my math lab and you're reading the problems, I want you to know. So this is called an inconsistent system. If you are visualizing the picture, what you have here, these two lines, they're parallel. Again, that's just for your notes on the test. The only thing on these problems I'm concerned about on the test is, yeah, you can identify what's going on and you just tell me what the solution says. Okay, so you don't have to tell me that they're parallel. You don't have to tell me it's inconsistent, but I do want to know what the solution is. If two lines are parallel, do they ever intersect? Nope. So that means that the solution set is the empty set. There is no solution. So that is solution set for an inconsistent system.